For today's video, we're going to go over two variable linear inequality examples. We're going to do 6 exercises. We're going to be graphing linear inequalities. I'm assuming you can already find the x and y intercepts there. It's pretty much the same as two variable linear equations, so there's no difference there. What we're really going to focus on today is mainly graphing. So we'll be looking at dotted lines, dashed lines, solid lines, and shading to find our solutions for our inequalities. However, before we get to graphing, we're going to have one problem that'll go over solutions to an inequality, and we'll start there. So our first problem is we're going to determine whether four xy coordinate pairs are a solution to an inequality. So the inequality we're going to look at is the inequality we're going to look at is free x plus 4y is less than or equal to 20. And we're going to see if 3, 1, 2, 4, -5, 10, and -1, 4 are solutions. Okay. Now, in order to see if these are solutions to our inequality, all we have to do is plug them in. So 3, 1, 3 is our x, 1 is our y. So we're going to get 3 times 3, I'll choose green for this. 3 times 3 is 9, plus 4 times 1 is just 4. And so that gets us to be 13. And so we need to say, is that less than or equal to 20? In that case, it is. So 3, 1 is a yes. It is a solution. We'll move on to 2, 4 now. 2 times 3 is 6. 4 times 4 is 16, so 6 plus 16. That gets us 22. And so in this case, 22 is not less than or equal to 20, so this is no. Next problem we're going to deal with is -5, 10. -5 times 3 is -15. 10 times 4 is 40, so we're going to get -15 plus 40. That gets us to 25. And in this case, 25 is not less than or equal to 20, so this is also a no. And that'll leave us with -1, 4. So -1 times 3 is -3. 4 times 4 is 16. -3 plus 16 gets us -13, and that is indeed less than or equal to 20. And so that is a yes. Okay. For the next problems, we will be graphing these inequalities. We're going to have 5 examples of these, and that'll finish out this video, but we'll get there in a moment. We're going to start off with 4x plus y is less than or equal to 8. Okay. So beforehand, we've been using a t-chart. I'm going to do this a little bit of a different way. I'm actually going to put this into slope-intercept form first. And then using slope-intercept form, we'll graph this inequality. So what that means is I'm going to subtract 4x to both sides. And I'm going to get, on my left-hand side, I'm going to get y. is less than or equal to negative 4x plus 8. Okay. Now I have to graph this inequality. So I'm going to straddle just the 2 pages here. Okay. Looking at my slope-intercept form of the equation, y is less than or equal to negative 4x plus 8. 8 here is telling me my y-intercept. So that means I'm going to go up 8 spots. So 1, 2, 3, 4, 5, 6, 7, 8. And so my y-intercept is right here at 0, 8. And then using the slope, it's going to say to go down 4 over 1. So a lot of times I'll write it as a fraction in this case. I'll write the slope as a fraction, so that way I remember I need to go down 4 and then to the right 1. And so if I use forest green here as a different color, I'm going to go 1, 2, 3, 4, and then over 1 spot. And so my next point will be right here. Now I can continue this pattern, do one more. 1, 2, 3, 4, and then over 1. And my next point is right here. So I have a couple of points. I have one point at 1, 4, which is in the middle here. And then I have another point at 2, 0. Now, with having 3 points, I can graph the line, or you can use just 2 points. Note that this is less than or equal to, so we're going to have a solid line. And so I'm going to have a solid blue line here. And now we need to plug in a test point to see where to shade. Now in order to plug in a test point, I'm going to use 0, 0, which is located here at the origin. And we're going to see if that makes sense or not. So when I plug in 0 for y and 0 for x, I get 0 is less than or equal to negative 4 times 0 plus 8. I'm going to go ahead and write that out. So I'm going to get 0 is less than or equal to negative 4 times 0 plus 8. Negative 4 times 0 is 0, so I get 0 is less than or equal to 8. And that is true. Since it's true, that means we're going to shade towards the origin, which means any answer to the left of our line is an answer. Okay? All right. That solves the first inequality. We have a few more to do, so let's go ahead and do the next one. The next inequality we have is 15x plus 5y is greater than or equal to 20. Okay, so for this one, we can either use a t-chart or we can use slope-intercept form. Technically, and looking at this, I believe slope-intercept form will be better. There's a shortcut you can use. Note that all of these numbers are multiples of 5, and that means you could divide all of them by 5, and you'll get a lot simpler numbers to work with, which would help if you want to choose a t-chart. However, for this, I'm just going to use slope-intercept form. We'll use a t-chart in the next example. It'll have some smaller numbers that are a little bit easier to work with, especially if you're trying to graph. Okay. So I'm going to subtract 15x here because I want to get this into slope-intercept form. I'm going to get 5y is greater than or equal to negative 15x plus 20. I'm going to then divide both sides by 5, or technically multiply both sides by 1/5. Let me go ahead and do that. So if I multiply both sides by 1/5, looks something like this. On the left-hand side, I'm going to get y is greater than or equal to negative 15 times 1/5 is negative 3. (20 times 1/5 is 4, so I'm going to get negative 3x plus 4. Okay. Now let's go ahead and graph this. Two, 3, 4. Okay. Since this is in slope-intercept form, 4 is my y-intercept. So I have 1 point here at 0, 4. And then if I use my slope, which is negative 3 over 1, I know I'm going to be going down 3, 1, 2, 3, and then over 1. And I have another point right here at 1, 1. Okay, let me go ahead and connect the dots here, or connect these 2 points. Since we have a greater than or equal to sign, it's going to be another solid line. And so we'll get something like this. Last thing we need to do is shade. So I'm going to use a test point here. I'm going to choose good old 0, 0. And so with the origin, we say we have 0 is greater than or equal to negative 3 times 0 plus 4. And so in this case, we say 0 is greater than or equal to 4. Is that true? That's not true. And so since it's not true, that means we shade away from the origin. So that means any answer to the right of our line this time is a solution. Okay. All right. Let's move on to another problem. We have 7x minus 3y is less than 4. And for this, I'm going to use a t-chart. Okay. I'm only going to get 2 points this time. I'm going to get my x-intercept and my y-intercept. Starting with my x-intercept, we're going to plug in y for 0. And so that means I'm going to get 7x is less than 4. I'm going to divide both sides by 7 now. And I get x is less than 4/7. On the other hand, for my y-intercept, I'm going to plug in 0 for x. And so for this one, I'm going to get negative 3 y is less than 4. I'm going to divide both sides by negative 3. And I get y is less than, actually not less than. That's, well, actually, technically it doesn't really matter for the less than or equal to sign. Technically it's y is greater than or equal to negative 4/3. But keep in mind when you're solving these, if you look back at my previous video, we really just need this to be an equality sign. So technically when I wrote these, I actually should have had an equal sign here. Not less than or not greater than. It should have just been an equal sign. And so that just means my y-intercept is negative 4/3. Okay, now that I have my 2 points, I can go ahead and graph these. So I have 4/7, 0, and 0, negative 4/3. Okay. Go and use white. Let's see, our first point is 4/7, comma 0. Right, 4/7, comma 0. Double check. Yes. Okay, so imagine if this is 1 here, then 4/7, comma 0 is going to be a little bit better than 1/2. So if I had 1/2 here, 4/7 would be right about here. Okay. Okay. And then negative 4/3, comma 0. Yep, negative 4/3, comma 0. Sorry, I was double checking something on my notes. It's true. Negative 4/3, so if we have, let's say negative 1 is right here, and we have negative 2 being, let's just bring this down a little bit, negative 2 being, let's get a little bit better spacing here. Let's say that this is negative 1. This down here is negative 2. Then negative 4/3 is approximately right here. Okay. And so now I just need to connect the line between these. Since this is a less than sign, this is going to be a dotted line or a dashed line. I always grew up with it being called dotted line, but recently in books they start using dashed, so we're going to use dashed. Alright, now we just need to find a test point to see where our solutions lie. We're going to choose good old 0, 0. If you can choose the origin, please use the origin. It makes things so much simpler. I'm going to work down to the bottom right here. I'm just going to rewrite the equation we had. We had 7x minus 3y is less than 4. I'm going to plug in 0 for both of these. And so since I'm plugging in 0, I get 0 is less than 4. And that is true. And so that means we're going to shade towards the origin. Awesome. All right, we have 2 more equations to go through. And then we'll be finished with this video. So, let's see. The next 2 ones are going to be kind of tricky. We're going to have one equation be y is greater than 5x. Okay. So y being greater than 5x. There's a couple of different ways we can solve this one. For this one, we could use a t-chart, or we could use slope-intercept form. For simplicity, I'm just going to use slope-intercept form. And so that 5x actually tells me my slope. And in this case, I have nothing for my y-intercept, but in hidden truth, my y-intercept is actually just 0. I can always add 0 to any equation and it's still true, or any inequality and it's still true. So in this case, my y-intercept is just 0. So if I want to graph this, it's going to look something like this. 2, 3, 4, 5, 1. I have a y-intercept at 0, comma 0. And then if I move up 5 and over to the right 1, I have the point 1, comma 5. Okay. Now since this is just y is greater than 5x, it's going to be a dashed line. So I'm going to switch to my light blue here. connecting my dots, and we get our dashed line. Looks something like this. All right. Now, here's the tricky thing. This point, this line is going through the origin. So can we use 0, 0 as a test point? The answer to that is false. Since we're going through the origin, we can't use 0, 0 as a test point. If we were to plug in 0, we would get 0 is greater than 0, and that would make no sense. So instead, let's choose a different point. I am going to choose the point 3, 0. Sorry, 0, 3, right here. Zero, 3. So 3 is my y value, 0 is my x value. And if I plug that into my equation, I'm going to get 3 being greater than 5 times 0. And then I get 3 is greater than 0 because 5 times 0 is just 0. And so that means everything towards that point is a solution. So I'm going to shade to the left of my line. Awesome. All right, we have one more equation to go through. I'm going to just jump to a new page here. Our last equation is going to be x is less than 7. That's tricky. X is less than 7. How do we graph that? Well, we can't really use a t-chart, or actually we could use a t-chart. We can't use slope-intercept form really because we don't have y, but like I said just earlier, we can use a t-chart. So if I have x and y values, no matter what I plug in for y, no matter what I plug in for x, sorry, I'm always going to get the same thing for y, which is 0, I believe. Actually, hang on a moment. Yeah, let's not use a t-chart. Let's just go ahead and graph this normally. So if I was thinking x is equal to 7, if I was thinking that, I would have this line. 1, 2, 3, 4, 5, 6, 7. Here's my point. No matter what value of y, if I go up or down, I'm still at x is equal to 7. So if I have a point up here, I'm still at x is equal to 7. If I have a point down here, I'm still at x is equal to 7. And so I have a line going all the way up and down x is equal to 7. Since it's x is less than 7, I have dashed line. So I'm going to get something like this. Okay. And now we just need to shade. So if I plug in 0, 0, since I can use that, if I plug in 0 for x, I'm going to get 0 is less than 7, which is true. And so anything to the left of my line is a solution. Okay, so that even includes the negative numbers all the way beyond 0, 0. All right. That will conclude this video.